My name is Vijay Keswani, and I'll be presenting our paper on implicit diversity in image summarization. This is joint work with my advisor, Professor Elisa Celis at Yale University. The goal of image search and summarization is to condense a large dataset of images into a small representative sample. However, search algorithms working with images of people often suffer from the problem of bias. For example, if we look at the Google image search results for the keyword CEO USA, we find that only 10 to 11% of the top results are images of women, whereas in reality, around 27% of CEOs in US are women. Similar gender disparity exists in search results for other occupations as well as for results beyond image search. Prior work to address biased image summarization has a number of limitations and falls into two categories. The first is to use non-redundancy approaches, which basically consider vector representation of the images and then aim to diversify across the entire feature space. The main disadvantage with this approach is that non-redundancy does not always lead to diversity with respect to protected attributes such as gender or race. The second approach is to use these gender race labels to form fairness constraints on the summary. And the main problem with this approach is that it requires two accurate protected attribute labels, which may not exist if the images have been scrapped from different sources. And automated label inference can in itself be inaccurate or very biased. Therefore, we ask if there are methods to correct for visible diversity in image results that do not require protected attribute labels. To address this question, we propose a simple post-processing framework. A normal image summarization algorithm would take a dataset S and given a query Q, it will use an image matching algorithm A to rank the images according to query relevance with respect to Q. Due to possible biases in dataset S or the algorithm A, the summary generated by this approach can be biased. And to address this bias, we introduce a small set of representative samples that we call a diversity control set. In our simulation, this set contains of equal number of images of men and women, as well as equal number of images across racial categories. Using this set and the dataset S, we can construct a pairwise similarity matrix, which can then be combined with a query relevance score using a hyperparameter alpha. Our algorithm finally sorts each row of this final matrix and returns the images with the best score in each row. And this simple post-processing approach is effective in ensuring that the summary is visibly diverse in a similar manner as a diversity control set. We evaluate our algorithm using a new data set of Google image results for 96 occupations collected in December 2019. The primary metric for evaluation is the fraction of images that do not correspond to the gender stereotype associated with the occupation, where the stereotype is defined using the ground truth of the gender distribution using Bureau of Labor and Statistics data. We observe that the summary generated by our algorithm is relatively more gender balanced than Google images. The second metric for evaluation is the fraction of images of dark-skinned people, which is defined using the Fitzpatrick skin type 4 to 6. And once again, there is more balance across skin tone for gender stereotypical images. And there is a larger fraction of images of gender anti-stereotypical dark-skinned people in the summary generated by our algorithm. The main observation regarding our framework is that it does not require any protected attribute label at any point during its execution, and it can be used with any black box image summarization algorithm A. Regarding the diversity control sets, they are the primary source of diversification in our framework, and therefore they should be representative of the entire user demographic. Their composition can be context specific, but it has to take into account community feedback and regular audit. In terms of future work, there's a huge scope for extending this framework in terms of improving diversity with respect to skin tone, as well as using context-specific similarity metrics to get better performance. The framework can also be extended beyond image search, and the potential is huge. That's it for the presentation, and if you have any questions, feel free to ask them during the Q&A session. Thank you.